Okay, so we discussed in the last class the finding the turning points and finding the nature of turning points, and this is a past paper question in front of you. So they're asking you for the first part finding the dy by dx and the double derivative d square y upon d x square. So the two derivatives, the first two derivatives. So y is equals to 54x minus 2x minus 7 power 3. Now we will differentiate using the rules of differentiation that we have done previously. So look at over here, your first derivative, y dash, the first dash. 54x, the power of x is 1. It would go down, multiply with 54, so it stays 54, and the variable gets removed. So it will only be 54. Then for the bracket, we will use the rule of the bracket. So the 3 power comes down and multiplies. So this becomes minus 3. Bracket doesn't change. And the bracket power reduces. It becomes 2. The power was 3, now it becomes 2. And now, one more thing, the derivative of the inside of the bracket. So 2x becomes 2 and 7 becomes minus 7 becomes 0 because it is a constant. This is your first derivative. Let me simplify, rewrite it. 54 minus this 2 and 3 would multiply. So minus 6 into 2x minus 7 whole square. This is your first derivative. And then for the second derivative, you would apply the same rules of differentiation and differentiate it again. So 54 would become 0. Then minus 6 is the coefficient of the bracket. The 2 power comes down and multiplies with minus 6. The power bracket reduces by 1, so it becomes 1 now. And the derivative of the inside, it is 2 minus 0. Simplify. Minus 12 times 2, which will become minus 24. So minus 24 into 2x minus 7 power 1. This is your second derivative. This is it. So easy 4 marks. Then they're asking you find the coordinates of each of the turning point, the stationary point. So for the stationary point, you equate the first derivative to 0. dy by dx, simple one, is equals to 0. So 0 is equals to 54 minus 6 into 2x minus 7 whole square. Now simplify things. 54 would go over there. Minus 54 is equals to minus 6. 2x minus 7 whole square. Minus 6 would go over there. So minus plus 9. Minus 54 divided by minus 6. Look at my working. The whole square would go over there and become plus minus under root 9. So your x answers will be 7 plus minus 3 upon 2. So the two turning points would be 7 plus 3. 10, 10 upon 2 will be 5. And 7 minus 3 is 4. 4 upon 2 is 2. So these are the two turning points. The x coordinates of the turning points. Stationary points complete. Now you want the value of y as well. Not just the value of x. So for the y, 54 times 5 minus 2 times 5 minus 7 whole cube. Use your calculator. 243. 54 times 2 minus 2 into 2 minus 7 whole cube. 135. So the two turning points that you will tell them is 5 comma 243 and 2 comma 135. These are the two turning points. Then determine the nature of each of these points, nature of the turning points. So now you will use the second derivative. You have turning points at x is equals to 5 and at x is equals to 2. You will find the value of the second derivative minus 24, 2 times 5 minus 7. This comes out as I think this would be a positive answer. Minus 24 into 10 minus 7. Negative answer. Negative 72. Which is less than 0. So therefore this would be a minimum. 5 comma 243 is a minimum. Because it is less than 0. So that it is maximum, sorry. Less than 0 per maximum. And if it is 2, 4, this becomes 4. This is positive. More than 0, therefore this is minimum. 2 comma 135 is a minimum. This is it. Final answer. Complete question. So you got 9 marks. Okay. Any questions, anyone? Okay. Now the next thing. Increasing, decreasing function. Increasing and decreasing function. This is also a very simple thing, but I don't know. Every year the students make it complicated themselves. I don't know why. So what do you know? Increasing function is when your graph is going upwards. This is increasing. This is also increasing. But what you can see, as your x is increasing, your y values are also increasing in both of these cases. So this type of a graph is an increasing graph. Similarly, this is decreasing, the graph is coming down. This is also decreasing, the graph is coming down. You can see as your x is increasing, your y is decreasing. Your x is increasing, your y is decreasing. So now what is that? What is the thing which they ask you to find? They ask you to find the regions where your graph is increasing or decreasing. They ask you to find where the intervals of x, sometimes the values of x for which the graph is going up or for which the graph is going down, if it is increasing or if it is decreasing. And how do you do this? It's also very simple. In both of these, if look at this increasing function, if the graph is going up, you can see that the tangents, it is always positive. The tangent gradient is always positive for any increasing part of the graph, because the tangent is positive. Change in x upon change in y, both of them are positive. Change in x is also increasing and the y is also is increasing. So change in x upon change in y, sorry, change in y upon change in x, sorry, change in y upon change in x, both of them are positive. So the gradient stays positive for the curve in a increasing part of the graph. So this means for the increasing graph, the dy by dx always stay positive. This is the condition that you use for an increasing function. For a decreasing part, you can see the change in y is negative, change in x is still positive. So negative, positive, it becomes negative. So the gradient stays negative for a decreasing portion of the graph. So in this case, the dy by dx is less than 0. What about the value where your graph is neither increasing nor decreasing? What do you have then? If it is not decreasing and not increasing, what would it be then? Rayan or Manib?
Straight line.
What? Straight line.
I don't.
It would be the turning point. For example, in this, let's suppose I'm using this as an example. This is your quadratic graph. You know about this. You have three portions of this. This portion and this portion, and exactly at the turning point. So for the yellow part, you can see that the graph is coming down. The graph is coming down. So in this portion, all of the gradient derivative, sorry, all of the gradient of the tangents would be negative. On this part of the portion, your gradients are all positive because your graph is going up. And exactly at the turning point, your gradient is zero, isn't it?
Yeah, makes sense.
Your graph is coming down, so all your gradients would be negative. Your graph is going up, all your gradients are positive, and at exactly the turning point, the turning point is where your tangent is horizontal, so the gradient is zero. What type of a graph is this? This is a exponential graph, but for all values of x, you can see for all values of x, this is a graph of y is equals to e power x. So for all values of x, you can see the graph is going up, isn't it? Always going up. So this is a the gradient, the dy by dx is always positive for x belongs to all real number, all positive, no negative x values. So this is a continuously increasing function. The graph will keep on increasing, increasing, increasing. It is never coming down, and there is no turning point as well. मुनीब समझ आ रहा है नहीं आ रहा?
जी सर आ रहा है।
Y is equals to, where is it, e power x. So the graph is, look, keep on increasing, increasing, increasing. It is never, the graph is never coming down. Let's suppose it is y is equals to x cube. What about this? You can see that the graph is again always increasing except at the x value 0, isn't it? The turning point is 0 comma 0. This is where your tangent will be 0, sorry, horizontal. Otherwise your graph is keep on increasing, the gradient is positive, so this is always also a increasing function. Let's do another example. X into x minus 2 into 2x plus 6. Now in this example, you have different things happening. Let me bring this thing on the, every year I try to make it as easy as possible, but things, students, I don't know why they always complicated. Now if I ask you where is it increasing or decreasing, first of all, how many turning points are there? Munib?
सर 2।
Yes, this one is the turning point, and this one is also a turning point. So this is the maximum, and this is the minimum turning point. You will find this by finding the derivative and then equate it to 0. Then if I ask you where the region, where for what values of x is the graph going upwards, the graph is increasing. Yes, Rayan. Between what values of x is the graph going upwards or increasing? It is increasing.
From -3 to -1.7.
This portion, yes, it is increasing, and the portion before this as well. All of this is the graph is coming up, isn't it? So this is the increasing portion of the graph, and this is also increasing. Okay, because over here as well the graph is going upwards. Over here as well the dy by dx will always be positive. The only part where your dy by dx is negative is this part when your graph is coming downwards. Okay, getting it? So over here your derivative is less than 0 because the graph is coming downwards. Over here your derivative will always be positive because your graph is going upwards. And for this part as well, your derivative will be positive. Graph is going up here. On the turning point, your derivative will be 0. Do you get it? Any questions, anyone? Munib and Ryan.
No, sir.
No, sir.
I am giving you more information than required. I am giving you the background of it so that you can use your brain, not just use the formula. You know the condition and how this is happening. Now you also know about the background as well. Why and how and everything. You can visualize the things as well once you have your solutions. And okay, look, determine whether this function is increasing, decreasing, or neither. Neither means that it is both. Okay, it is decreasing and increasing both. If they're telling you that it is increasing function, this means it is always going up. If they ask if it is a decreasing function, it means it is always going down. If it is neither means it is going like this, turning. It is increasing and decreasing both. So this is what we have to find. And how do we find? We have to work on the derivative. The first derivative tells you. So you will differentiate. So your fx is 3x plus 1. First you bring the denominator above. This becomes minus 1 plus x squared. And now you differentiate it. So minus 1 comes down. 3x plus 2 power minus 2. Sorry. Multiplied by 3 plus 0 plus 2x. So now you have the first derivative. It is minus 1 upon 3x plus 2 whole square plus 2x. And they have given you that your x values are all less than minus 1. So don't forget. So we can input the values of x less than minus 1. And we have to see using algebra. You don't have the graphs, okay? Using algebra, what will be the values of the first derivative that you get? If it is positive, if it is negative, if it is both. So if we work on this part, if your x values are less than minus 1, you know this is 3x plus 2 whole square. The whole square, regardless of any value of x that you put in over here, it is always positive. The whole square, negative square is also positive. Positive square is also positive. So the first term, minus 1 upon a positive number, would always be less than 0. Because negative upon positive would be negative. Okay, so this portion, for all of these values, this portion would remain negative. All good till here? Any
Yes.
questions? Manip?
No, sir. So much.
Then, now this is always negative. We have known this. Then this one as well. If I input the values of x as less than minus 1, all of the negative values of x, this would always be negative, isn't it? Minus 2, minus 4, minus, because you are multiplying a positive number with a negative number. It will also be negative. So this means that for all the values of x less than minus 1, it is negative plus a negative number, which will remain negative, which is less than 0, which means that your function is a decreasing function for this portion. Okay. For all of the values that they have given you have used algebra, you have used your calculator, and you saw that you will only get a negative derivative value, negative gradient. So this means the gradient is always negative for this values of x. So this means it is decreasing. It is always coming down. Okay. Any questions?
No, sir.
No. Let me show this to you on the Desmos as well. 1 upon 3x plus 2 whole square. Oh, sorry, the function is this. And then plus x square. And for all of the values, x is less than 0, right? Less than minus 1 log, isn't it? So for all values of x, you can see as well, the graph is always coming down. है ना? Always coming down. समझ आई logic?
Yes.
Ryan and Munib.
Yes, sir.
But you won't have the graphs. You have to visualize this. This is happening to your graph. This is how your graph is moving. And are there any turning points? Sorry, yaar, हटा दिया. 1 upon 3x plus 2 plus x square. हैं? पहले तो कुछ और आया तो है ना? हाँ, look ऐसा. So it has a turning point as well. Look, this is your turning point. 0.2146, comma 0.4240, and this is the minimum turning point. It has an asymptote as well. 2 upon 3. Negative 2 upon 3. Asymptote. Okay. Okay, good. Copy this down. This is a very important thing. I hope you understand this properly.